Well, I'm really pleased to host this or moderate this discussion with John Lombardi and Mike Gargano. They've been just really great colleagues in terms of our explorations of issues of education. John and I have been doing this, I think, for about 5 years now in one area or another. John is the one with all the expertise. He's been a senior executive at 5 or 6 universities, and he's a historian. So he brings historian's perspective to the studies, not just the system engineering or system science perspective. Mike has been there and done that. He's run so many things in terms of efforts to improve education, and is deeply involved with Connecticut, where he lives, and some of the data that we'll show you in a bit. One of the things most of the readers, the audience here, might not realize that STEM education that produces people with engineering degrees or math degrees, et cetera, is not the only thread of importance. Okay, not only do you want engineers to design complex systems, you want the people who can maintain and operate these systems. And as these systems are getting increasingly complicated with artificial intelligence and sensors and other things, these tasks become more and more difficult, and people need technical training to do this. You can't come out of high school and just go ahead and start maintaining AI systems. It just doesn't happen. And this trained technical workforce or skilled technical workforce, there are huge demands for people, and it's hard to find employees who actually have the skills you need. And John and Mike are going to tell us a bit about why that is and what kind of programs have worked in the states that we've investigated. So John, it's all yours.
Well, thank you very much. I'm glad to talk about this a little bit. The first thing to point out, of course, is that my colleague, Mike Gargano, had a family emergency and isn't able to be on this webinar, but I'm happy to substitute for him because I can parrot pretty much everything that he talks about, because he and I have been colleagues for many, many years. Now, I think if we could go down just a little bit on our slide, next slide item. Yeah, keep going. Yeah, okay. What we want to start out recognizing right away is this complex ecosystem of higher education that we have that goes from the community college, the 2-year colleges to the 4-year colleges. And these little charts that we have, we can explore in more detail later, but the important thing to look at is the relative structure of these, which is that we have really 2-year colleges and 4-year colleges. And while they go up and down a little bit, it's a very stable structure. Right? And while the news is always full of the opening and closing of colleges and the crisis of the moment, we don't want to forget that over time, as we have represented here for maybe 10 years, there's quite a bit of stability to this system, and it doesn't change all that much. Let's have the next slide. As you see, what we have here over three years, we can see that the number of institutions stays fairly stable, with the exception of the for-profit colleges. The for-profit colleges, of course, have been through all kinds of turmoil and change over time, in part because of how they're structured and financed and regulated. But the core of the public and the private not-for-profit colleges, the 4 years are very stable. The 2 years have had some difficulties in the recent period as enrollment has fallen off in those. But otherwise, again, we have a relatively stable set of institutions. Let's see the next slide. Here, if you look at the level and the control of these institutions, you can see that we have in the 4-year institutions, we have indeed in every one of these categories, we have a lot of institutions that are quite small, that are less than 1,000 students. And then as you go down the list, you see that we have a small number of institutions that are very large, and especially in the public university sector and private not-for-profit. But this is deceptive because although there aren't very many institutions that are large, they have a very large number of students. So we really have to pay attention to these different contexts, because it's from these large universities, the last two categories here, that you get most of the students being generated. Okay, let's see the next slide. Now this slide is important because it shows two things. The first is that the top line is the actual and the projected enrollment, and it goes all the way to 2030. And basically this is stable with a slightly upward trend. But if you look down below, you see the two-year colleges, and they're much less stable because they were high in 2010, 2011, and then they dropped down and have sort of stabilized at a much lower level, right, for the projections for the subsequent years. So that the two-year colleges are likely to suffer the most significant change in their enrollment patterns, in their curriculum, and in their programs to deal with the changes in enrollment, whereas the four-year colleges are much more stable. And while they suffer from time to time for rising and falling small amounts of enrollment, and they make a big difference perhaps year to year, nonetheless, the overall trend is for continued and slow growth in the population of our four-year institutions. So let's see the next one. Now I'm going to pretend to be Michael Gargano. So imagine that I'm somebody else, and let's move on. Now, one of the critical things that we want to try to highlight here is the process below the collegiate enterprise in which the states in particular and the industries in those states have worked together to try to construct systems that promote the development of skilled technical workforce. And the key in this getting the skilled technical workforce trained up is to have the kind of system in which both the state and the industries agree on what they're going to do to develop these people. And part of it has to do with the specificity of the needs for each state. So it's really the industries in those states that define what skills they need, whether they need skills for working in industrial systems, or they need skills for working in cyber systems, or they need skills for people who can repair systems. Those are all a function of what kind of industrial base the state has. And so each state builds its own system for producing a skilled technical workforce that speaks directly to the needs of the industries in their state. So what we did, and Mike did, was to focus on the Connecticut system, which is one of the most developed and advanced enterprises to deal with the production of a skilled technical workforce to serve the industries and activities in Connecticut. And we learned much about the way in which these systems operate and what can be made, what could be done to make them most successful. So let's see the first slide. Now, as you can see, because Connecticut has Electric Boat, Pratt Whitney, Sikorsky, and Collins Aerospace has these defense contractors and receive a great deal of government contracts over the years, this means that we have a lot of manufacturers providing parts and services. And so they need lots of in-state people of technical skills to produce the kind of people the industries need to be successful with their contracts and their programs. Now, Connecticut State has a college and university system with 12 colleges, as you see, four-year regional universities and one online college, whose job it is to provide skilled technical workforce to the manufacturing sector. So let's see the next slide. Now, when we look at what is needed to produce a good technical workforce system, we identify these six key elements that we'll show you in the next slide. And every time you look at a state and you say, what is it this state does to produce workforce training, you want to look for it, the existence of these six elements in its technical workforce program. So in this case, we have, excuse me, the collaborative system, which means that the governance and the government and the industries have to collaborate in an ecosystem to be sure that it's successful. Otherwise, what happens is that we don't produce the right people at the right time with the right skills. The second thing, which is sometimes should be obvious, but isn't always, is that the consistent funding model is critical because this business of training technical workforce requires expensive equipment and systems. And if you don't have a consistent funding model, you can't get the flow of talent and prepared workers that you want for your workforce program. So one of the keys is to find a consistent funding model, because if you come up with money just one time and do something exciting, but that exciting doesn't continue into the next year or the following year, it's tough to get the equipment and the systems in place. You also have to have critical relationships between the employers and the producers and the trainers so that everybody is in the same, is sitting in the same place, seeing the same needs, seeing the same competencies, and working together to make this happen. Because if you just have the industries speaking or just the government speaking or the providers speaking, they may not be speaking about the same thing. And there's a lot of motion and funding that is lost. Let's see the next slide. Now, these are the second three elements that is required. You got to have a strategic focus, right? So you got to determine what are the skills and capabilities you need, because the skills that you need are very specific in this field. You can't just give some general set of training to people and hope they'll find jobs. You need to be very clear about the focus of your training programs, what you're investing in, and who's doing the investing. This is the fifth thing. You have to have a target workforce, right? And so you you have to have a program, as is shown here, that enables high school students to earn both a high school diploma and an advanced manufacturing certificate, right? And combine it with on-the-job training and be involved with the community college, so that when students graduate, they're ready to go to work, so that we don't have to do a second cycle of training. And finally, the sixth item, which is really critical, is you have to be able to evaluate what you're doing. Right? And often programs are full of high-sounding ideas and goals and purposes. But if you don't measure exactly what you're doing, you have no way to know whether the program you have is actually delivering the right people to the right tasks with the right skills. And so one of the key elements, which is perhaps not as sexy as some of the others, is that we have to be able to measure what people are doing. We have to measure what the programs are doing. We have to say what it is we're going to achieve, and then we have to measure whether we did achieve. And if we don't achieve those, we have to go back and make adjustments. So let's see the next item. So this sort of elaborates on these 6 topics, and we're taking in this case primarily the role of what happened in Connecticut, because it has such a well-developed program. So you have to have a governance and structure model that defines everybody's role, because otherwise what happens is that people have different ideas about what they're doing, and that produces a lot of lost motion. So you've got to have this collaborative ecosystem so that everybody is agreed about what it is you're going to do and how you're going to go about it. Next slide. Now, here we have a statutory charge from the Connecticut General Statutes that outlines what it is that the structure will be to produce this technical workforce. And we're not going to go through all the details, but the important thing to recognize is that the Connecticut legislature has created a statutory charge that creates a system to try to deliver the purposes of this training program. Next slide. Now, the second is to get a consistent funding model for the skilled technical workforce. And you can't underestimate how expensive these programs are. And although there's different ways of doing it through combinations of federal or state or private partnerships, the key is to have a consistent and reliable source of funds, because while it may look like we want to hire 10 people today, actually the training and development of these people and the production of a system and a classroom and a set of equipment requires time, and it requires consistency. And if you don't get that kind of consistent funding, you don't get the scale that's necessary to expand the workforce training programs as needed, and you won't be ready to add additional industry demands and needs as they become necessary. Next. Now, Connecticut has a manufacturing innovation fund, which institutionalizes the financial support for these programs. So it provides 75 million, as it shows here, for the fund for doing this. And this fund encourages the companies and the university to collaborate in research and development. It provides these vouchers for visit development and technical needs. It funds job training and educational programs and matches federal grants. But the key is to recognize that the state's economic growth strategy has advanced manufacturing generate almost 11% of the Connecticut's gross state product. So it's central to its strategic growth plans. Next slide. Now, relationships are very important if we're going to institutionalize these skilled technical workforce programs. And so you've got to have the money to be sure, but you have to have the linkage that connects education providers, business and industry, employers, and those who do the hiring. And these stakeholders have to be close collaborators. They can't work in isolation and send each other messages. They have to work together. And since the goal is, is to establish workforce skills by business, and the role of the educators is to establish learning outcomes that you can see embedded in both curriculum, internship, and apprenticeships, the relationship is based on a mutual respect, so that you have to have flexibility. Now, the goal is to have the business and industry help the institutional and training providers participate in curricular development, which is often closed off by the educational institutions. But we have to open that up and make sure that the employers and the providers of instruction are on the same page, looking at the same results and trying to get the same skills. Let's have the next one. So in this case, what happens in Connecticut is the aerospace components manufacturing sector helps define a set of needs that the Connecticut state colleges and the university system's 12 community college can together develop the curriculum and apprenticeship program that will train the people to go into entry-level positions. And the community colleges have manufacturing centers that enable students to practice on the same type of equipment and technology they will experience when they go to work. And so if you have this kind of collaboration between the providers of education and the purchasers of skilled technicians, you're much more likely to be successful, as the Connecticut program shows. Next slide. Now in this one, the fourth element in this is to have a focus to institutionalize the skilled workforce programs. You have to know exactly what's needed. And this is hard because often in education, we try to create people who can do work of all kinds in all places under all circumstances. But actually in these kind of workforce training programs, we need very specific needs. We need specific skills. And so we have to classify the jobs and the competencies and the number that we need both today and in the reasonably near future. So that we have to understand whether we're trying to create people who can work in entry level or mid-level or above. And so the education providers have to be clear in describing and creating a capacity to produce the training that's required to deliver a workforce that meets these expectations and needs. Next slide. So as you can see, here's a whole list of the high demand skilled technical workforce. Now, you can look at all of these and you can see that while many of the skills may overlap some, most of them require rather specific kinds of technical training, technical skills and abilities if they're going to enter at the beginning stage or the mid-level stage of participating in these programs with the skills that industry requires to hire people who can do these tasks. Next slide. And this is the fifth element in our conversation, which we want to institutionalize skilled technical workforce programs, which is to build them in so that we have a continuous and ongoing process that will prepare people to go to work with those skills in these industries. So Connecticut has an innovative program that it shows here that allows high school students to both get a high school diploma and an advanced manufacturing certificate from one of the community colleges, plus some on-the-job training at an industry manufacturing facility. So the goal here is that when you graduate somebody from one of these programs, they will be able to go to work on day one. Next slide. Now, one of the ways this is implemented is that these community colleges provide education through degree certificates or short-term programs, or some programs for people who are already employed but want to move on. They enroll about 3,000 students, as you see, in these programs, including engineering science offered by the College of Technology. But they graduate, to give you some sense of scale, about 630 students each year in advanced manufacturing programs. And the average 3-year graduation is 175 associate degrees and 460 certificates. So you can see from this that we're putting out people who have very focused kinds of credentials. Both certificates and associate degrees are focused. They're designed to meet the needs of industry in specific categories. This doesn't include, of course, the training programs or the non-credit programs that produce credentials that are usable in industry for people already employed or interested in moving up or expanding their capacity. There's also, through the community colleges, they generate, as it shows here, 125 additional graduates in computer information sciences. Now, of importance here is you see that 73% of these technology credentials are awarded as certificates. That means that the students that are engaged here are in a program that has very specific output that is designed to satisfy an employment need of business and industry. So we're not training people with general degrees that can be used in any purpose, but rather we're training people who have credentials that are focused on one of those categories we showed above, or one of those job categories. And finally, we can see that 80% of the graduates are employed by the first to third quarter on graduation. That means that the better the integration and linkage between the preparation and the hiring, the focus on the specific skills and talents, the more likely it is that the people we're working with are actually going to get a good job and go to work and help fill the need of the businesses and the industries involved. Have the next slide. Now, they have a number of different programs in Connecticut, which is why, of course, we focused on Connecticut. We have this voucher program, the incumbent worker program, and the Young Manufacturers Academy. The voucher program is the most utilized initiative, and it gives matching grants from $5,000 to $50,000 for new equipment, software, technology, research, and training. So when you do that and provide these funds, you can target them where the need is, where you know from business and industry and the collaboration we talked about above have allowed you to identify what the high yield areas are. The incumbent worker program is somewhat different because it's funded and it's administered by the Department of Labor, and it's designed to train current employees on new technology and processes. So it gives the company matching grants, and this pays for training that allows you to keep your employees upskilled into newest technology and can create the next cycle of leadership. And finally, we have the Young Manufacturing Academy, which is at a lower level, focused on the lower grades of 5 to 8. And the idea is to get young people thinking about what's needed and what's possible and what opportunities are available in manufacturing, whether it's CNC machining or engineering or factory design. This allows you to sort of prepare students before they get the kind of and go into the technical training, so they don't drop out after high school and leave the labor market, but continue on to the training needed to make them useful to the business and industry in Connecticut. Next slide. Now, this is our last key element in our conversation, which is the evaluation measures. Nobody likes evaluation, of course, because it's hard. And to do evaluation, you have to not just talk about what you want to accomplish, but you have to be able to design a measurement that allows you to know whether you succeeded in accomplishing what you said. So you have to know what you want to do. You have to know how many people you want to involve, and you have to know how to measure whether they achieve the skills that you set out to provide. So what this does is give metrics so that state government feels confident that their investment is going and producing what's needed, and it allows the businesses and industry to know whether or not they're receiving people with the training that's needed and the skills that they hope to have to be effective. And so you have to train, you have to track program outcomes. You have to be able to know whether the current and future workforce has improved their skills, improved their knowledge. And you have to be able to know whether the jobs and the job opportunities are being filled with qualified people because of the additional training and the formal education that these programs provide. Let's have the next slide. What Connecticut does, as you see, has been to try to evaluate the impact on the state's economy, because from the point of view of the funding that comes from the legislature, this is a key element. Are we improving our enterprise? Are we keeping the companies employed and successful? Now, as you know, the advanced manufacturing sector in Connecticut, employs hundreds of thousands of workers. And as you see, it accounts for 30 billion of the state's gross domestic product and generates about 380 million in state and other taxes that can be used to fund other statewide initiatives. Now, these numbers are helpful because it shows the direct jobs, a 3-time increase in indirect jobs. The indirect stuff creates another 459,000 jobs elsewhere. The tax revenue to the state by these initiatives goes up to about 380 million, and the companies, the advanced manufacturing companies, contribute about 145 million in state taxes and in corporate taxes, and another 236 million in state sales and use taxes. So this tells you that not only in exports and states' GDP, but this manufacturing sector is very effective. Now, what this means, of course, is you have to measure how well these programs are functioning to help increase these numbers. Next slide. So this allows us to summarize what it is, these key common challenges that we see developed in Connecticut, but apply to every state that we've looked at. We've looked at about 5 states. Mike spent a lot of time, Mark Gargano spent a lot of time working on this, and he's looked at about 5 states, and not very many are as fully developed in their programs as Connecticut, but they all recognize that these 6 elements that we've been talking about are the key structures required to have a successful program to sustain and grow skilled workforce training. So we got to quantify the demand. You got to know what growth and future growth and innovation will do to the demand for labor and what kind of labor, and we have to pay attention to retirement. Right. So getting a good mechanism is very difficult because it doesn't exist easily to capture these data points across the industry. We have to look at the money. Right, it's expensive. You have to do it right. You have to pay attention to the cost to the education providers to hire additional workforce programmers, get the people, the instructors, the internships, the apprenticeships, the facilities, the equipment, the technology. And often people think that, well, we can sort of repurpose what's out there. But often to be successful, especially in these high-tech enterprises, you have to have new equipment that matches the kind of equipment and the kind of issues and the kind of programs they're going to find when they go out to get a job. Because if you train people on obsolete equipment, or you train them with technologies that are no longer the most current, the value to the corporation is much less. And the funding sources, obviously, in order to meet these needs of the program, are critical, because if you just put a ton of money on the table and somebody rushes out and buys equipment, but there's no money to maintain the equipment, there's no money to upgrade it, there's no money to hire the people to train, then the program will wither and not be successful in providing the kind of people you need for this sort of program. Next slide. And these are the second three elements. Right? You have to understand that internships and apprenticeships, while they're not part of the direct educational process, they're a critical element in teaching people what they need to do. So if you can get the students to participate in internships and apprenticeships, two things happen. The first is they learn all about the places where they're working. And second, it gives business and industry a chance to learn about the people being trained and get them in a position to hire them when they complete their training. So you have to pay attention to what it costs. If you don't cover their travel expense and you don't cover other expenses associated with getting the training students to participate in these internships and apprenticeships, then they won't be able to participate and be successful. We have data. You got to have data. This is a real problem. We can all preach about what ought to happen, but if we can't measure it and collect data on who's coming in, who's going out, who's being hired, what are they being hired for, how often are they being hired, anything that you can measure and reliably collect data, it's very hard to get the information needed to improve, to enhance, to expand programs and serve the needs of business and industry in the state. And of course, staff attrition is a clear issue. You gotta pay attention to the fact that you need people to do the training. You need people to run these programs who have the necessary skills. And if they don't stay in these programs and leave, then what happens is the program will stop, will stagnate, will stutter. New people will come in and they will have different ideas and different agenda, and you won't be able to get the flow necessary to be successful to generate workforce needs of the business and industry. Next item. Well, I've preached enough, so now I'm going to give it back to Bill Rouse, and his job is to organize any kinds of questions and answers that might be needed. Bill?
Oh, Bill, you're muted.
I'm sorry, I forgot about that. So Bill Howell, you have some questions. Do you want to vocalize those? Is that feasible to do that?
Yep, absolutely. Bill, I think we can hear you now.
Bill Howell?
Oh, I see his question in the list.
Okay.
The first question is, do targeted training programs provide a stronger basis in the normal university program? The answer is that most of these training programs are not really university based in the sense of producing bachelor's degrees or master's degrees. These programs are primarily focused at providing a basis for specific targeted employee programs that require skills that are not necessarily as far advanced as you would get in an undergraduate program. And so it's not that it's a stronger or better basis, it's a different basis. It's a very specific purpose that the program is designed to provide.
And I want to go on with the next question, John, from Bill.
Yeah, I can't tell you that I know for sure how this happens, but we don't have
His mic is not working, but he may be.
Can you hear me now?
Yeah.
You can hear me? Because I always have problems with my microphone and all that. I'm just wondering, you do give a measure about what portion of the students who finish the program are employed within 1 to 3 quarters after graduation. But in a larger sense, would these programs tend to have controlled number of places going in? So you are a very targeted education training program, But will you generally have ups and downs of vast surpluses and shortages? Maybe not as bad as in the past. I guess that's the hope, but those will still occur. Do you have any comments on what happens afterwards? I mean, somebody who's gone through these programs still has a very good education.
I think the answer to that question is for the most part, we're still not producing a sufficient number of graduates from these specialized programs that fulfill the needs of business and manufacturing. Now, it may be in the future, if these programs become too successful, it's possible we'll overproduce, and therefore we'll have people who are trained but unemployed. But that's a danger in this conversation, because the needs of business and industry are very specific, and therefore when the business and industry change their need, they of course will no longer need to hire as many people who we might have been training for that need. But so far, that has not been a problem. The biggest problem so far has been that we're not up to a level where we're producing a satisfactory number of people who are fully trained for these specific employment categories.
Yeah, I think another factor, and I don't know how large it is, but I think there's a certain proportion of these graduates that decide to do something else. In other words, they don't stay on the path to go work for Sikorsky or to go work for Pratt & Whitney. They've learned from this educational experience, and so they decide, for example, to go to college.
Yeah, or they decide to go out of state. I mean, there's a lot of places they can go, but I think the real challenge of these programs in many ways is the specificity of the match between the training and the job needs of business and industry. and so as you get more people involved in the flow, right, it's possible that you will overshoot the need of business and industry, which is why the coordination is one of the key elements in this conversation, so that the providers are clear about how many people they need to provide, and the employers are clear about actually how many people they really need to employ.
Should we go on to Fred Robinson's question?
I'm ready. So my question, and admittedly, in the end of my post, I throw in the DOI. I did just thankfully get published in the INCOSE Insight issue, which was theme edited by SERC members about the special attributes of systems engineers. My focus is, after reading both Peak by Anders Ericsson and Range by David Epstein, and just been reading a lot about systems thinking, and then finally also Sir Ken Robinson, who is very adamant about the challenges in our educational programs, that it saps the divergent thinking out of many folks by the time they get into high school and continues into college. What do we do to try to inject critical thinking skills and systemic or systems thinking aptitudes into these STEM programs without necessarily pulling out something that is still foundational to the learning of the disciplines and domains that are included in most STEM programs? What are the thoughts towards that? Over.
Well, I have two comments. Obviously, you're absolutely right that teaching critical thinking is, of course, very difficult to instruct. It takes a lot of special care and feeding to get our students to focus on their ability to solve critical problems, to deal with unanticipated challenges that arise in the workforce and the economy. So there's no question that that's a key issue. At the same time, the programs that we have been focused on in this sort of narrow approach are more focused on instrumental kind of activities rather than on analysis kinds of activities. That is, their primary function has been to deal with things like welding and things like repair and things of that nature. which are much more easily defined than the problems that we would hope that our undergraduates who are getting a degree in engineering or a degree in math or a degree in something other STEM related will have to deal with, that require critical, high intensity problem solving. So I'm not sure that the kind of program that has been developed here to do these skills has room in it for the kind of development that we want. So I think you really have two issues here. One is, what can we do in the K through 12 system that will prepare students to go on into STEM degrees and develop these critical thinking skills? Issue that allows people who are not going to go on but still want to be employed in industrial systems to acquire the skills they need in the short time frames that are available post-college before employment that they're able to use.
You know, another factor here is the fact that the systems, and I'm much more familiar with automotive systems than defense systems, the systems are constantly changing. There's a new model every year. There are new functions and features. And my son works for Subaru, and my experience been, he gets an enormous amount of training from Subaru so he can actually work on the new cars. Every year it happens. And so he's not producing the same helicopter, say, for many, many years. And the reason I bring it up is because the training doesn't end, education training doesn't end when they exit this program. Once they are employed, often there's considerable education and training ongoing.
Let me also respond to Courtney Wright here, who asked whether stakeholders don't always know what they really want. And so this is a problem. It's one of the reasons that we try to have a close relationship between the employers, the businesses, and the education providers, so that the education providers don't imagine they know what the employer wants or needs, and they don't really know. And so if you can do these things together, the chances of getting a good match between what we're training people to do and what business and industry needs them to do are much more closely aligned. But I'm sure from time to time, it happens, as you described, where personnel pass verification but fail validation, where, they're trained to be a welder, and they go to work to weld, and it turns out they didn't learn the kind of welding that the industrial enterprise wanted them to learn. And so, again, this close collaboration needs to be developed, and needs to be sustained. It needs to be institutionalized. Otherwise, mismatches of this kind will surely occur.
So if I can follow up, I think, and one of my other penchants is for something called a jingle fallacy, when folks use a term, word, or phrase, and they have fundamentally different meanings and they don't realize it, which I sort of felt like I've experienced a little in this discussion, in that my anticipation of STEM education, and the E being engineering, has been to focus STEM towards the development of potential undergraduates, as opposed to the educational model of creating really good, powerful factory workers, which is the industrial age education model Ken Robinson talks about. And so it kind of sounds like there's a dichotomy of STEM education programs, one for focus on creating, if you will, the technicians and the technical staff who are being operators at the production level, as opposed to the engineers who might be working, and obviously there's overlap between these two groups, at the design and development and solving problems level, that might be more focused on the systems engineering kind of problem solving. Is there a dichotomy?
Yeah, I don't think there's any question there's a dichotomy. I think the training programs that we're talking about here are the first element that you recognize. There are people who are not ready, or not interested, or not prepared to go on to college and acquire the advanced skills that you described, but they want to work in these industries, and they have the capacity to be trained to be effective operators rather than effective engineers. Some number of those who go into these programs and think they don't either have the skills or the energy to become more advanced will find out as they do their training that they really do want to move up, and they will then go into what would really be collegiate programs of engineering or computer science or something else, which are dealing with higher level problems. But there is a dichotomy because these statewide programs are employment focused. They're focused on the job that the industry needs to produce their product. And that's not the same thing as the training that we would like to provide STEM college graduates or even advanced master's graduates. And that's a whole different category of both training and preparation.
But there is a bridge. My son got his associate's degree at SUNY in automotive technology, and part of what he earned was a guarantee to be able to go to get a bachelor's degree in SUNY, guaranteed acceptance, because he was part of the SUNY system. So he knows if he ever decides to do that, he has an acceptance already.
All right, thank you.
Well, very good. One question, John, since you've been involved with so many states, is how varied is the philosophy and strategy and investment thinking across states? Does Connecticut and Massachusetts and Florida and Louisiana all think about this the same way?
No, of course they don't. I think for the kind of programs that we have reviewed and then we have in detail on Connecticut, one of the key differentiators is what is the industrial base in the in the state, because the state, if it has manufacturing for heavy duty defense and they're making tanks, is not going to need the same skills as a state that has a heavy investment in cybersecurity. And so when a program is state focused, that means that the program is designed to meet the needs of business and industry in that state. And so they're not interested when they're producing one of these programs in Wyoming about what Massachusetts needs. They don't care about Massachusetts because the program comes from the state, initiated by the state, and it comes in collaboration with the state's industries. And the goal from the part of the goal from the state's point of view is to increase the economic prosperity of the state and the state's businesses so they can be taxed, so that the citizens can get jobs. And so the programs differ substantially state by state, both with what they train and for whom they train it and how they train it. So what we did was try to identify the 6 key elements that are required for a successful program, whatever the end result is. That is, whatever the industry is that's involved, whether it's a computer-based industry or whether it's a production-based industry or a defense-based industry.
So how can system engineers help? Well, one of the things I think is interesting is that we have started to look at the overall project we're pursuing as a supply chain problem of talent and people. And that's something that systems engineers and designers are used to looking at. And it's not the way educators think about it. So there is an opportunity for engineering thinking to influence this process. Okay, well, I think we've done a pretty good job here with 55 minutes or whatever. I really appreciate it, John. Sorry Mike wasn't here. He has endless, really compelling stories that related to all this, and but we'll keep moving on because I think, as one of the participants said, there is a dichotomy. Not everybody needs to get a BS in engineering, and we do need some people who keep these systems actually running. Do you have any wrap up, Mimi?
Just thank you again for the great discussion. As some other folks pointed out, we will be discussing this topic as well at next week at our annual research review. It is being held in Washington, D.C. with a hybrid option, so feel free to click on the slides or in the link in the chat to register today. And following up in December, we'll be closing out our Innovating for STEM Readiness series with Dr. Rita Colwell. Registration should open up soon, and we'll be sure to send you more communications on that, as well as the playback of today's talk. So thank you again.
And Rita is going to talk about what's the role of the federal government in this, from her perspective from being at NSF. So you'll see from the three talks from Rich DeMillo and John and Mike, and then Rita, we could cover quite a spectrum of issues and opportunities.
Yep, and feel free to send questions or comments on those talks to myself at Emeritus@students.edu. We'll incorporate them in the next talk, but we hope to see you there.
Okay, thank you. Thank you, John.
A pleasure.